In this video, I will discuss about the order and degree of a differential equation and as well as its linearity. So first, let us see what is a differential equation. So any equation involving an independent variable, a dependent variable, and as well as the derivatives of that dependent variable is called the differential equation. Suppose we have a function like this, and suppose we have an independent variable x, a dependent variable y, and the derivatives of the different dependent variable can be denoted as dy by dx, d2y by dx2, and etc. So any equation involving these terms can be called a differential equation. So here we have some examples of the differential equation like this one here. Here we have the dependent variable as x, the independent variable as t, and the derivatives of the dependent variable is here also. In this case, there exist two types of differential equation. One is called the ordinary differential equation, also known as ODE, and another one is partial differential equation, which is known as PDE. So ordinary differential equation involves the ordinary derivatives or the normal derivatives of a function, and the partial differential equation involves the partial derivatives or partial differential equation of a dependent variable. So here we can see that these three equations, the first three equation involves the normal differentiation, as this y depends only on x. This is a function of one variable, and this x is also a function of one variable, which is like x equals to xt. This one here is a function of x, y is the dependent variable and x is the independent variable. Also here we have y of x, and here we can see that the dependent variable depends on two independent variable, which is v of x and t. So these three equations where we have only one independent variable, those equations involve the normal differentiation. So these three are ODE, as it has only the normal differentiation. But in these two cases, we can see that here we have more than one independent variable. So for this case, we have two independent variable x and t. For this case, we have three independent variable. U depends on x, y, and z. So these cases where we have more than one independent variable requires partial differentiation. So any equation involving those partial differentiation can be called a PD. So PD or partial differential equation. So these three here are ODE, and these two here are PD. Now moving to the order, degree, and linearity of the differential equation, let us first define what is order. So order of a differential equation can be defined as the highest order derivative that is present in the differential equation. So next, let us define the degree. So the degree of the highest order derivative is defined as the degree of the differential equation, provided the differential equation is free from radicals and fractions. So I will explain it later when. So let us first see an example. Suppose we have, let me denote the derivatives as dash. So suppose we have y dash equals to y double dash square plus sine y. Okay, so the highest order derivative present in this equation is 2. So this differential equation has order 2. As for degree, what I said is that the degree of a differential equation is the power of the highest order derivative, provided it is free from radicals and fractions. And also the equation should be in a polynomial form in the dependent variable and its derivative. So here we can see that as for this example, we have y dash and y double dash, but there is a sin y term. So this sin y term cannot be represented as a polynomial in y dash or y double dash. So let us see another example like this. Y dash equals to y double dash square equals to sin x. So what is degree? Degree is the degree of highest order derivative. There is one thing, and it should be free from radicals and or fractions, and it should be polynomial in y, y dash, y double dash, etc. Okay, so let us see this equation first. So for this equation, we have the order as 2, as it has the highest order derivative 2. Next for degree, so 2 is the degree of the highest order term, and this equation is free from radicals. Free from radicals means there is no this type of term, and free from fraction, there is no fraction in this equation, and this is expressed as a polynomial in y dash and y double dash. So this equation has order 2 and degree 2. However, if we see this equation here, it has order 2, okay, but the degree, for the degree what we need it to be expressed as a polynomial in y dash and y double dash, but there is a sin y. It cannot be expressed as a polynomial in y. Therefore, the degree is not defined. So the order of a differential equation is always defined, but the degree may not be defined for a differential equation. Next, for the linearity part, for linearity, the simplest test, there is a form of linearity which I will discuss in some another video, but for linearity, what we need to check that the degree of y, degree means the highest order, the power, degree of y, y dash, y double dash, etc. means other derivatives too, should be 1. And there should not be any multiplication term with y and its derivative. Okay, so suppose we have a differential equation like this: y dash plus y double dash equals to y into y dash. So we can see that the degree here in this case, the order of the differential equation in this case is 2. There is no problem with that. Also, the degree of the differential equation here is 1, as the highest order derivative here has the power 1, and also it is free from radicals, it is free from fractions, and as well as this is expressed in a polynomial form. So the degree is 1 and order is 2. As for linearity, this term has power 1, so there is no problem. But there is a multiplication term between y and y dash. So this is not a linear equation, linear differential equation. This is a nonlinear differential equation. So if we move to the next example, so the previous examples, so what we can see here is that in this case, let us now check the linearity and the order and the degree of the differential equation. So first let us come to order of each of these differential equations. So for this, the highest order derivative present is dy dx. So it should be 1. It should be 1. Wait. So it is 1. Here, the highest order derivative present is 4, obviously. Other is 2 and 1, so it should be 4. 4. For this here, the highest order derivative is again 1, as dy dx is the only derivative present here. So this is 1. This one here has highest order derivative as 3. It is 2 and this one is 3, so it should be 3. So in case of partial differential equation, it does not depend which independent variable is present. It may be x, it may be t, that does not matter. As for this case, the highest order derivative present is 2. So again, the order is 2. Now let us come to the degree. So as for this, the dy dx, it can be expressed as dy dx equals to x plus sin x. So obviously the highest order derivative dy dx has power 1, so no problem, and also it is free from radicals and fraction, and it is expressed in a polynomial in the derivative and the dependent variable y. So it should be 1. This one here, it has again this one as the highest order derivative and the power of it is 1, and it is again free from radicals and fraction. So it should be 1. But this one here, it has the highest order derivative dy dx, but what happens is that there is a fraction term. So what we need to do? We need to remove this fraction. How can we do that? We can do it by multiplying this term here. So it can be expressed like this: y into, I'm writing the dy dx as y dash equals to root x y dash square plus k. So now it can be seen that the highest order term here, this one, highest order term is what? It is 2. So the highest or the degree of the differential of this differential equation is 2, as the highest order derivative has power 2. So again, this should be 2. As for this, we can see that the highest order derivative is 3 and it has the power 2, and again it is free from radicals and fraction. Therefore, the degree of the differential equation is 2. And as for this case, again the highest order derivative has power 1, therefore the degree is 1. Now let us come to the linearity and non-linearity. So as for this, it can be expressed as dy dx equals to x plus sin x. So this one here, there is power 1 for the derivatives and as well as the dependent. There is no dependent variable. Dependent variable has power 0, and these are the independent variable. This does not matter in case of linearity. So it will be linear. For this one here, the derivative, one of the derivatives has power 5. Therefore, it cannot be linear and it is non-linear. For this case, it can be expressed in this form. So here again we can see that one of the derivatives has power 2, and also there is a multiplication term between the dependent variable and its derivative. Therefore, this is again non-linear. This one here again, it has degree 2, so it is non-linear. And here it has degree 1, and all the terms here has degree 1. Therefore, this one is linear. Okay. So one thing can be noted: if the degree is greater than 1, it is non-linear. But the converse of this statement is not true. As we can see, suppose we have this equation here. So suppose we don't have this 2. Let us assume that this one is 1. Then this equation will be a equation of degree 1, but it has a multiplication term, therefore it is non-linear. Okay, so let us now see some more examples to understand this thing. Here we have this differential equation. So let us now check the degree, order, and the linearity part. So as for the degree, so as for the order, we have the highest order derivative as 1. So the order is 1. As for the degree, the highest order derivative has power 1. We can see that we have power 1 here, power 1 here, and the dependent variable y also has power 1 here. Okay. And for the linearity part, it is linear, as all these derivatives, y has power 1, dx has power 1, and there is no multiplication term between y and dy dx. Okay, so this one is linear. Okay, so this one is a good example. So highest order derivative present is 1, therefore order is 1. For degree, there is a radical term, as there is power half. So we need to remove it. How can we remove it? We can do like this: dy dx equals to a into 1 plus dy dx square power half. So if we square the both sides, we will get y x dy dx square and also a into 1 plus dy dx square. So the highest power of dy dx is 2. Here it is 2 and here also 2. And also, as the degree of this differential equation is greater than 1, it is non-linear. Okay. Moving to this example, here again see, order is what? Order is 1. Sorry. Order is 1. Degree, the highest power of the highest order derivative, is again 1. And also this one is linear, as there is a y term, there is y dash term, there are no power terms of these, and these terms are not multiplied here. So this one is linear. Here order, highest order derivative, that is 2. For degree, free from radicals, free from fractions, and is expressed as the polynomial, and the highest order derivative has power 2, therefore order 2 and degree 2, and as the degree is greater than 1, this one is non-linear. Okay. So this one here, this has order 1 degree. So degree is interesting in this case. See, sine of dy dx. So this term here, this cannot be expressed as a polynomial in the derivatives. Therefore, degree is not defined. And as the degree is not defined, therefore, this is non-linear. Okay. And this one is the last example, and again see, there is sine y, so it cannot be expressed as a polynomial in y dash and those terms. Therefore degree is not defined. However, order is always defined, and here the order is 1, and this term here is nonlinear as the degree is not defined. Okay. So with this, I end this lecture. Thank you for watching the YouTube channel.